Hello everyone. Sorry for the inconvenience. The live stream wasn't successful because of the poor connection. So I decided to record this video. I'm going to record 3 questions of the second assignment and upload it, and you can ask your questions below. So what I'm going to explain is the common mistakes that many students make and give some tips for the final exam. These 3 questions are absolutely important, so please give your full attention and hopefully you will get some good advice for your final exam. All right, so the first question. Let's go to the questions and see what are they. The first question is asking us, is Friday the 13th bad for your health? The data below are from a 1993 British study which examined the number of people admitted to emergency room for vehicular accidents on 12 Friday evenings, 6 Friday the 13th and 6 Friday the 6th. So if we're here, we've got the data, 6 and 13th of each month. So what is the question asking us? Part A is asking us, are the accidents reported on the 6th and 13th paired or independent samples? Are they paired or independent samples? Write a sentence justifying your choice. Okay, how do we do that? In order to know whether this is paired or independent sample t-test, we need to recall what is the difference between them. So normally in paired sample t-test, we care about the differences between pairs more than the variations in the numerical variables. So I write it here. We care more about the differences between pairs than the variation in numerical variable, than the variation in numerical variable. This is one thing that we should bear in mind. And the second thing is, normally in paired sample t-test, observations are somehow paired across samples. So observations are paired. So how do we know that observations are paired across the sample or not? Let's see if we can find any clue in here. If you look at this, if you look at the question, we see that the question is telling us we've got 2 Fridays, right? So there is some sort of association between them. Both of them are showing us Friday 6th and the 13th of every month. So we can probably go with, and we care about the difference between these 2 Friday days. We want to see whether there is any difference between them or not. So probably we can go with a paired sample t-test. So the answer for the part A is paired sample t-test, and the justification that you can write, you can say that we are looking we are looking for the difference between 6 and 13th, and there is somehow a connection, an association between these 2. That's why we can use the paired sample t-test. So you can have other justifications as long as it is reasonable. We don't have any problem with that, okay? So part B is asking us, carry out an appropriate hypothesis test with 5% significance level to investigate whether Friday 13th, this is important, look, Friday the 13th is worse for health than other days. Be sure to state the null and alternative hypothesis, t-statistic, null distribution, p-value, and appropriate conclusion. This is all we need to do for this question. Okay, so how do we do that? First of all, we want to write the null and alternative hypothesis. How do we write that? The null hypothesis and alternative hypothesis. If you read the question carefully, the question is telling us the thirdings is worse than the 6. Look, the question is telling us whether Friday 13th is worse for health than other days. So because the question is telling us whether 13 is worse, it is one-sided. Imagine we've got 5 accidents in here, so here we probably have 10 accidents, just an example. And the differences between these two, the mean differences is greater than 0. If 13 is worse, the mean differences is greater than 0. Alright, 10 minus 5 is 5, so it's the difference is greater than 0. Here in alternative, we can say the mean differences is greater than 0. And the null hypothesis would be the mean differences equal to 0. So okay, that's the point. It's one-sided. If the question was asking us whether the 13th is better, if the question was telling us whether the is better, so then we should say we should change this mu mean of differences smaller than 0. Okay, that would be our alternative hypothesis. But now it's asking for the it's asking us whether the 13th is worse or not. Worse, that would be the worse, and the better, this is what we are looking for. All right. So many students here, they wrote the alternative hypothesis, mean of differences not equal to 0. And null hypothesis, mean of differences equal to 0. Well, absolutely null is true, but the alternative, we can't say this is, the mean is not equal to 0. That is a two-sided one. All right, so make sure that you know what you're looking for in alternative hypothesis, whether you're looking for one-sided or two-sided. Okay, so that's our null hypothesis and alternative hypothesis. What else is the question is asking us? We need to report the test statistic, null distribution, p-values, and a conclusion. So if we proceed with the question, if we use the SPSS to generate the output, we will have such a thing, all right? Well, we will give you this in the final exam, so you just need to interpret the result and extract the information that you need. What we need is the TS statistic. Here we go. That's the TS statistic over there. And we want you to also the report. Sometimes we need the confidence interval. It's here, you can report it, but in this question we don't need to. We also need the degrees of freedom and the p-value. Note that the p-value in SPSS is actually shown with significance, so that's what you need to report. Okay, so to answer this question, what is the TS statistic? It's 2.712. What is the null distribution? This is important to know. The null distribution, when H null is true, is T distribution with 5 degrees of freedom. Many students do not say the degrees of freedom, do not mention to that, but we need that. All right, so make sure you report the proper null distribution. And how do we figure out the degrees of freedom for paired sample t-test? For paired sample t-test, degrees of freedom is equal to n minus 1, and n is the number of groups that we have. We've got 6 groups, 6 minus 1, 5. This is the null distribution. All right. What else? We want the p-value. So the p-value here is given 0.042. This is the p-value for two-sided. This is another mistake any students make. You need to know When it is one-sided, you need to divide this p-value by 2 to get the p-value for one-sided t-test, a paired sample t-test. Okay, so 0.02 divided by 2 is 0.042 divided by 2. That's our p-value. That would be 0.021. What do we do? What is your conclusion? Because this value is smaller than 0.5, we reject the null hypothesis. Reject null hypothesis. Okay? One thing that I should mention in here is that you either reject the null hypothesis or do not reject the null hypothesis. Do not reject H null. So if p-value is smaller than 0.5, that's what we do. If p-value is greater than 0.5, that's what we do. 0.5. But we never accept it. Okay, don't use this term. If you want to interpret it properly, either you reject it if H null is, if p-value is smaller than 0.05, or this is 0.05, or you do not reject it. Okay, so that's about part B. What else we've got in here? The question is asking us in part C, state and check the assumptions that are necessary. State and check the assumptions that are necessary for the analysis in part B. So what are the assumptions of paired sample t-test? We've got two assumptions for paired sample t-test. Probably you can write this in your cheat sheet because assumptions are always important to know, and we want you sometimes to report us. So one thing that you can, there are two assumptions. All right, what are they? First, the observed differences are independent. Note that we have observed differences. We want to see the differences are independent or not. Okay, many students forget about this because this is a paired sample t-test. We care about the differences between them. And the second assumption is the differences. Okay, again, the differences come from a normal distribution. Come from a normal distribution. Or the sample size is large enough. Is large enough to rely on central limit theory. Okay, let's see if they are met or not. Observed differences are independent. The way that you can answer to this assumption is just by looking at the question. See if there is any information given to you. If you read the question, we haven't given any information. We haven't given any information about whether they're independent or not. So don't be afraid. We can sometimes say that they are not independent because there is no information given. Or in best case scenario, you can explain and say, okay, we haven't given any explicit information about them, that whether they're independent or not, but because 6 and 13s, there are two different dates with some distance between them, so we can assume that they are independent. Okay, so this is one way to justify the answer, and we have given you this justification in here. You can see we haven't give you any information about it, whether they are randomly selected and they're independent or not. And then we know that it may be reasonable to assume that the sample differences are independent because each of the dates are quite far apart. That's about it for the first assumption. What about the second assumption? So for the second assumption, we had either the differences come from a normal distribution or the sample size is large enough to rely on central limit theory. So the sample size, when we say sample size is large enough, that means n is greater than, well, 25 or 30. We've got different numbers in here, but what we have in here is only 6. So we've got only 6 pairs, so we cannot really rely on a central limit theory. What we do, we need to plot the we need the normal QQ plot. If we do that, we will get such a diagram. In this graph, you see that these differences between these are the differences between 6 groups. These are actually lie around this straight line. Most of them are close to this line. So we say that it's reasonable to assume that the differences come from a normal distribution. Okay, so this is about the first question. If you have any question about this, please comment below and I will get back to you